from room 544. This is Captain Booby. Take it away.
Why, thanks, Charlie. That was a great introduction. We're going to do number 9 here. This is a pretty basic problem with Unit 7.6. And I think you've seen a problem like this before. It was example 3 from the video from the other night, very similar. So this is one of these problems where they give you a graph and they want you to write it out in factored form. What leads the way here in factored form? A, which is called the what? Starts with the D. That. Yes, sir, it's the dilation factor. Very good. We're going to find that last. Does anybody remember what to put in for R1, R2, and R3? The zeros. Very good. So the one is negative 5, 0. The next is 3, 0. And the last one is 6, 0. And as we do this, I'm going to show you what would happen if there was a double root. I'll do that in a minute. But all we'll do here is x minus negative 5, or x plus 5, x minus root 2, x minus 3, x minus root 3. Now, let's pretend for a moment, don't write this down, but just watch. Let's pretend that the graph would have done this at 3. If the graph would have done that at 3, there wouldn't have been a third root, and the x minus 3 would get squared. When it bounces off like that, if it would have gone, boom, like that, and turned back up, again, the x minus 3 would have been squared, and there wouldn't be a third root. That's the approach you'll take in some of these other problems. All right? There's another called a triple root, which I thought this would be a good time to say how to handle that. Here's how a triple root works. Let's say it goes up like this and comes down, and then it changes direction like that. You see how it's kind of opening this way, then it turns? That little change in when it comes like an S curve like that, that means there's a triple root there, and instead of being squared, it would be cubed. And that's as far as we'll look. All right? So again, if the graph would bounce off and go up, it would have been squared. If it would have gone from opening this way to that way, if it would have done an S curve, it would be cubed. Since this example has none of the above, it just slices through and slices back. There's no squared, no cubed. Now let's finish the problem for part B by finding that scale factor. Can we use the y-intercept in this problem? Yes, because it's not 0, 0. That would be bad. If it was 0, 0, you would pick any other point on the graph to plug in for x and y. Since it's not 0, 0, we can go ahead and use 0, 180. So 180 goes in for y, while zeros go in for all the x's. And all you get is 0 plus 5, 0 minus 3, and 0 minus 6. Finish the problem by finding a. By doing 5 times 3 times 6, 2 of them were negative. So will it be positive or negative? Positive 15 times 6, 90. And if you have 90a equals 180, what's a? 2. So now we know the equation in factored form. It's y equals 2 times x plus 5 times x minus 3 times x minus 6. This will definitely be a problem for you to understand for the test next week. It's the unit test for all of Chapter 7. For Part C, they want to know, what would you do to this graph to make the whole thing shift up 100? And you can check this on your calculator as well. To add 100, to make it shift up 100, you just add the shifter at the end, just like we did with a parabola or a line or an absolute value or any other graph. Plus 100 would move it up 100. For part D, they want to know how you would make it shift left 4. That's a little trickier. See all these X's? Put them in red. You see them? Now, how did we make a graph? Like, how did we make x squared go left 4? We did x plus 4 in parentheses. How did we make an absolute value go left 4? Add 4 in there with the x. So it's kind of like you have to go into this little x here and put a plus 4 in. Watch what happens. Basically looks like this. That x becomes an x plus 4 plus 5. We'll simplify it in a minute. This x, to make the whole thing move left 4, would have to be an x plus 4 before the minus 3. And this one would have to be an x minus plus 4 before you do the minus 6. Forget about the up 100. This is a different problem. We're just making it go left 4. Will that have an effect on the x-intercepts if they all go left 4? They should all shift left 4. Well, what does x plus 4 plus 5 become? X plus 9. Remember, we used to have an x-intercept of negative 5. Now we have an x-intercept of negative 9, which is 4 units to the left. We used to have an x-intercept of, up here, positive 3. This one is negative 1, which is 4 units left. Finally, what's x plus 4 minus 6? X minus 2. We used to have an x-intercept of 6. Now it's at 2, which is 4 units to the left. That concludes this problem. Thank you.